Okay, this is going to be the video lesson for the second part of inverses. Okay, this is sort of some applications of the inverse concepts. Okay, find the inverse and then find the domain restrictions. Okay, we learned last class how to do this. Okay, I just want to talk about domain restrictions, so I switch x and y. Okay, subtract 3 over here, x minus 3. All right, and I squared the square root. All right. That's going to be x minus 3 squared, okay, with y minus 8, and then I would add 8 over to the other side, okay? So my inverse is x minus 3 squared plus 8, okay? All right, and that's the easy part, okay? Now let's talk about the domain restrictions, okay? So let's think about if I graph this simple graph here, 3, 4, 5, 6, 7, 8, 1, 2, 3. Here would be my anchor point, 8, 3, right? Okay, we talked about how to make a table. You guys are all good at this by now. Square root of x is 1 and 4, so 1 and 2, right? So 1 over 1 up, 4 over 2 up. So this is what it would look like, okay? All right, infinity, infinity, okay? So let's talk about domain. Let's find the domain and range. So the domain for this, okay, smallest would be 8, biggest would be infinity. Range, smallest would be 3, biggest would be infinity, okay? Now, when you find the inverse, okay, so the domain restriction for the original was this one, okay? Now, when you find the inverse, you're basically, the domain becomes the range and the range becomes the domain. So the domain restriction now is not 8 infinity, it would be 3 infinity, okay? So whatever is your range now becomes your domain for the inverse, okay? So it switches. That's how you figure that out, okay? So go ahead and pause your video and go ahead and find the inverse and then find the domain restrictions. If you want to, you can find the domain restrictions first, okay? But go ahead and pause your video, okay? Unpause. If I graph this, okay, that would be my anchor point, my table. Okay, 1 over 1 up, 1, 2, 3, 4 over 2 up. It would look like this. That's 4, negative 2, or negative 4, negative 2, sorry. That's infinity, infinity. So my domain would be negative 4 to infinity. My range would be negative 2 to infinity. So I automatically know that my domain restriction for the inverse will be negative 2 infinity. So it's just the domain and range flip, okay? And let's show that. All right, x plus 4, okay, switch the x and y, add 2 to both sides, x plus 2 equals that. Let's square it to get rid of the square root. So x plus 2 squared equals y plus 4, because the square root and square eliminate. Subtract 4, inverse, x plus 2 squared minus 4. Okay, so that's the inverse, and then that's the domain restriction, okay? All right, now, let's talk about how you can verify inverses. There are 2 ways, and I would do one way for a certain type of problem and another way for another, okay? One way you can do it with a simple function is if you do the composition of f of g of x, and it equals x, and you do f of g of the composition the other way, if they both equal x, so it's like you do the composition one way, it equals x, the other one, you do it the other way, it equals x, that means they're inverses of each other. So if I started with the f function, okay, and then filled in the g function, cube root of 5x plus 35, okay, the cube and cube root cancel each other out, okay, this means I divide them both by 5. Okay, this would be 1x, 7, minus 7. The result here is 1x, just like I was hoping to get. Now I'd start with the g function. Cube root, 5 parentheses plus 35. I would put the f function in there. X cubed over 5 minus 7. I distribute that. That would be cube, 5 times that would be x cubed. 5 times that would be negative 35, plus 35 there. Those cancel each other out. The cube of x, cube root of x cubed would just be x. So that's a way you can verify that they are. Now for the rationals, I would do something a little bit different. The rationals, I would actually just find the inverse. Okay, so it's going to be y equals 7 over x plus 1. Okay, x equals 7 for y. Okay, I would move this 1 by subtracting. Okay, and this becomes like a whole term. Okay, so this y is going to come up. Okay, we worked on this last class, and now I can move that back down underneath. Okay, and if you notice, that's the same as that. That's good. Okay, now let's find the inverse of this one. X equals 7 over y minus 1. Okay, this comes up next to x. Okay, and then this can move back underneath. Okay, and then I just add 1 back over here to the other side. And as you notice, this, same as this. So that's another way you can do it. And that's the way I would do it with the rationals. I would just do the algebra and show both sides. So you can do one or the other. Okay? Okay, so what I'd like you to do is go ahead and pause the video. Okay? And go ahead and do the composition verification for this one and the arithmetic verification with that one. Okay? You can unpause. So what I'm going to do is I'm going to do f of g of x, g of f of x. Oops, g of f of x. Okay? All right, so if I start with f and put in my square root of 4x minus 4, squaring a square root will get rid of that. And then this division here, that means they're both divided by 4. That would be 1x minus 1 plus 1. These cancel out, I'm left with 1x, so that's good. I would start with g on this one. Okay, so big square root 4 minus 4. I would put the x squared over 4 plus 1. Go ahead and distribute that. That's 1x squared plus 4 minus 4. Those cancel each other out, so 1x squared would just be x, so that's good. Okay. I think that I left off a plus 3 here. So, okay. All right. So what I would do here is I'm going to do the arithmetic one. That would be this. Okay. I'm going to switch the x's and y's. Okay. So this is going to come up. Okay. Which okay, and then this x will go back underneath. And then I'd add 3 back over here to the other side. Okay? And that matches that. Okay? Then I would just do the same thing over here. Okay, switch your x and y. Subtract 3. This now is my full term. Now this would come up, and that would go down. Okay? And as you can see, this matches that. Okay? So that's how I would verify. Okay? All right, going on to the last thing here. All right, we want to talk about determine if the inverses are functions. Now, I want to bring you back to this concept that said, we said if I drew a graph like this and did the vertical line, this would be not a function. Okay? It was not a function by the vertical line test. Okay? All right, and that's the way we did it before. We've done that before, the vertical line test. Now, here's how you figure out if are the inverses functions. The way you test this is you do the horizontal line test. Okay? So, all right. Now, someone's going to say, Mr. Evans, how do we know what these graphs are? All you got to do is look at what the parent function is. Okay? So for this one is a line. Okay? So the idea behind the horizontal line test is if I've got any graph, okay, and I wonder is the inverse a function? If I do a horizontal line just like that, if it passes through more than once, then that answer is no. All other situations are yes. So if I do this, only passes once, that first example is yes. X squared minus 4, well that would be the x squared function, which would look like this. All right, so let's look at this. If I drew a horizontal line, 1, 2, so that answer would be no. Okay? What's this function? This is the step function. Okay? This is the step function. So be careful. The idea here is if I made a horizontal line, it passes through all these points. So this is also no. Okay? What is this one? This is a rational function. It's the one we do this. Okay, now this is the one also to be very careful of. It looks like this answer would be no, but along the way, this is getting decreasing. Along the way, this is getting decreasing. So this one actually is yes. Okay, so be very careful with the rational. This is the the square root function, which looks like this. Draw a horizontal line. This would also be yes. So here's the way you can tell. If it definitely crosses through more than one, that is no. The ones to watch out for are the rationals. Those inverses end up being functions. Okay? So here's what I'd like you to do. Okay? I would like you to use the horizontal line test to come up with whether these inverses are functions. Okay? So this one is absolute value, which looks like a V. All right, and so this answer would be no. This one is a line. So that answer is yes. This one is x squared. What do we know about x squared? That looks like these. That also would be no. All right, this is the step function. We know the step function looks like this. All right, that's also going to be no. Okay, this is a rational function, and this is the one we got to be careful of. Okay, this one would be yes. Okay, so that's a graphical way of using the horizontal line test to figure out whether the functions, the inverses will be functions. And that's pretty much the end of the unit. Okay, all right, a lot of arithmetic in this unit. Make sure you really do some practice. Look at those formatives to help you prepare for our end of unit summative.